All right, we are now going to do this example where we prove that the limit of 4x minus 5 equals 7 as x approaches 3. Now, what this means is we're going to prove using the precise definition of limit. One way to do this would say, well, it's a polynomial. And so why don't I just plug in, use direct substitution. It's a polynomial, therefore it's continuous. So I can just put in 3, and that gives the answer is 7. But there's what we mean here is use the precise definition of limit. We're not going to use the fact, which is given by a theorem in the previous section. We're not going to use the fact that a polynomial is continuous. So we're just going to leave that out and use the precise definition. This right here is what I'm going to show you is a format that I'm going to ask on tests that people follow. And it is not the only format, but I think it's a good one, and I think we should do it. It will save everybody a lot of trouble if you follow this format. Some people say, well, no, I'm doing it this way. And that might be good, but then we might have an argument, well, I think you should show here and there. So let's just, so we can just do this. Okay, so and this format is worldwide. Like I had this, I had to pass some language exam to get a degree in math. And so I read this book in French, and they set up the whole thing. They just have a different word. Otherwise, it's exactly set up. In this particular French book I was reading, it was a math book. Okay, it's worldwide. They might just have some different words in French, but it's the same setup. So here, I guess that's just a sample of France and the US, but still, this is how it's done. So we use the word given epsilon greater than 0. I think in French they said soit, but I could be wrong. But there's some other word, but we say given. Also, I sometimes hear people say let epsilon greater than 0. Okay, we're going to use given. I think we should, because that's what the book's doing. Okay, given epsilon greater than 0, comma, choose delta equal. All right, so this is what we're going to do, regardless of anything else. We're just going to start off the theorem, the proof this way. That's what we're going to do. So it's, it makes the reader comfortable, like, I see what they're doing. They're doing this, they're doing a proof where they're using the epsilon delta, definition, and everybody goes along with that. Now, it turns out that delta depends on what epsilon is, and this function here, 4x minus 5, is a line, right? We know that. And in fact, maybe I'll just on the side do a little aside, which is not the answer. I'm just going to do an aside and just make a little list of things. F of x is our function, and it's 4x minus 5. Now, if the function is a line, I'm going to tell you the trick. The trick is that when I'm choosing delta, it's going to be epsilon divided by the coefficient of x for the line. However, with absolute value. In this case, the coefficient is 4, absolute value 4 is 4. But it just works every time for lines. All right? But it's not enough for us to just write that down. We need to show that this is going to work. Now, also, I'm going to write down this aside that A, the number x approaching, is 3, and the limit is 7. All right. Now, above here, we have the precise definition of limit. I'm going to follow along that. I'm going to just fill in the blanks. I'm going to say then if 0 is less than the absolute value of x minus a, but in this case a is 3, and it's less than delta, then, all right, so we're setting this up where we're making the assumption that delta is epsilon over 3, epsilon over 4. Delta is 1/4 of what epsilon is. The epsilon is 1 over 1,000. Delta is 1/4 of that. Okay. Epsilon is 1 over a million. Delta will be 1/4 of that. All right. So I'm setting that up, and also I'm assuming that the distance between x and 3 is less than delta. By the way, why would it have to be greater than 0? It's greater than 0 because we do not want x to equal 3. If x equals 3, we'll get 3 minus 3 is 0. but we don't want x equal 3. We want to get x close to 3 when we do the limit, but not equal 3. Now, what I'm going to try to show is, as the definition here of limit says, I want to show that if absolute value of x minus a is less than delta, that something's going on here. What am I highlighting? But anyway, okay. I want to show that if absolute value of x minus a is less than delta, then f of x minus l is less than epsilon. So I have everything. I chose delta. I'm making x minus 3 less than delta. Now, to satisfy the definition, I'm going to work on this now. I'm going to figure out what f of x minus l is. Well, I'm not going to figure. I'm going to write that down, and I'm going to show it's less than epsilon, given my assumption that delta is epsilon over 4, and that x minus 3 epsilon value is less than delta greater than 0. So let's see, f of x, let's fill in the blank, is 4x minus 5. And L is 7. So I just fill in the blank there. And then I do what I would do even if I didn't have any idea what was going on. I'd say, even if I'm stuck, I'll just simplify. Minus 5, minus 7, let's just do that. Maybe if I'm stuck. Next thing I'd say, well, why don't I just try to factor? How can that hurt? Okay, but once I factor, I'm thinking, oh, hold on. I see something going on here. I see x minus 3 is less than delta, and here's absolute value of x minus 3 right there. See, so things are starting to come together. Now look at this 4. Let's pop the 4 out. Now when the 4 pops out, that's something we're allowed to do. But actually what I'm doing is I'm popping, it comes out there, and I'm taking the absolute value. So what I'm doing here is, this a little aside, that if I have absolute value of a times b, this is equal to absolute value of a times absolute value of b. We don't need to write that down each time. I'm just writing that here. So when I take the 4 out, I take the absolute value. So I want to point out absolute value, or emphasize that, because if that had been negative 4, when you take it out, you make it positive. Okay, now that's one aside. Another aside is, if 0 is less than absolute value of x minus 3 is less than delta, then if I multiply by 3, or no, 4 times 0, that's less than 4 absolute value of x minus 3, less than 4 delta. Right? I'm just multiplying everything by 3. By 4, I said 3 more than once. By 4, I multiplied by 4. So this 4 times x minus, that's the value of x minus 3, is less than 4 delta. Right? I have right there in green, absolute value of x minus 3 is less than delta. I didn't need to do that aside. I can just see, multiply both sides by 4, and I get 4 absolute value of x minus 3 is less than 4 delta. But now I go over and say, what's going on over here? Well, delta is equal to epsilon over 4, so I'll just go ahead and substitute that in there. That's equal to 4 times epsilon over 4. And now, without just doing simple algebra, that equals delta. I think that's done. Some books will then say, they do a little summary. This shows that if 0 is less than absolute value of x minus 3 is less than delta, then the absolute value of 4x minus 5 minus 7 is less than epsilon. I don't even like doing that. I would just leave that off and finish the proof above. It just makes it more stuff. I'll just put the box there. That means the box means I'm done with the problem. Some people, they don't write both, but some people write QED, which is Latin for, it's a abbreviation for an acronym for a Latin expression, which means that we've proven what we meant to prove. So actually, I don't think, I'm just gonna, I like it nice and neat. I don't even want to put that junk there. Just put it like that. I mean, it's what I wanted to prove. I wanted to prove that if the distance between x and a is less than delta but greater than 0, then f of x minus l is less than epsilon. I mean, it's a little bit more than that. It's saying that it is, so I didn't say the important parts over here. that if for every epsilon greater than 0, that's why I said given epsilon greater than 0, anyone, then I can find a delta. And I did find the delta. The delta is epsilon over 4. So I was given the epsilon greater than 0. I said, okay, let's make delta epsilon over 4. Why did I do that? Because I've done these problems a bunch of times. And I know from experience that I take the coefficient of x, which is 4, and take the absolute value and just put it in the denominator. But here I have delta is epsilon over 4. And so look, I have absolute value of x minus 3 less than delta. Then I go absolute value of x minus L equals, and I just simplify until I get 4 times absolute value of x minus 3. And then I say, well, that's absolute value of x minus 3 is less than delta. Okay, that gives me 4 delta. And now I put in epsilon over 4. And this shows that was a good choice because those 4s cancel out. If there was no cancel there, I would do something else. But it did work. The 4s cancel and I got epsilon. I want the very end to be epsilon. Okay, well, that's all I'm going to say. I'll just turn off the video here. So go ahead and do that. Turn off. I'll get rid of that piece there. Okay, let's finish up.